Hello everyone! Welcome back to my YouTube channel. This is your teacher Marlene, and let us look up and discover the world of kites. Let us see how to prove theorems on kites as indicated in the most essential learning competency number 30. Let us start and see the wonders of kite. It is a quadrilateral with two pairs of adjacent sides that are congruent. Let us illustrate kite with vertices K, I, T, E. The adjacent sides that are congruent are KI and IT. Another part of the kite, the adjacent sides that are congruent are KE and TE. The special kind of kite is the rhombus. Let us look for the other properties of kite. It states that the longer diagonal bisect the shorter diagonal and formed right angles. In our illustration, the longer diagonal is IE and KT is the shorter diagonal. The two diagonals intersect at point S. Again, it is stated that the shorter diagonal is bisected by the longer diagonal. Therefore, KS is congruent to ST. Let us put the tick marks. Then these diagonals are perpendicular to each other. That's why they formed right angles. Therefore, angle IST is equal to angle ISK and is also equal to angle TSE and is also equal to angle KSE, and they are all equal to 90 degrees. Another among the properties of kite is that the two angles are equal where the unequal sides meet. Let us draw our kite and let us name this as kite MAPE, where the sides MA is congruent to side AT, while side ME is congruent to side TE. Now sides AM and ME are unequal sides that meet at vertex M. The same on this side where AT and TE are the unequal sides that meet at vertex T. Therefore, the angle AME is congruent to angle ATE. Now, there is a theorem which states that the area of a kite is half the product of the lengths of its diagonals. So using the illustration, the area of kite MATE is equal to 1/2 times the length of AE, which is the longer diagonal, times the length of the shorter diagonal, which is MT. So let us prove this theorem. So using the figure, Our given is kite ROPE with diagonals PR and OE that intersect at point W. So we have to prove that the area of the kite ROPE is equal to 1/2 times the length of OE times PR. Now let us complete the columns for the statements and reasons. So the kite ROPE with diagonals PR and OE that intersect at point W. Of course, this is indicated in our given. Now, if the diagonals of a kite are perpendicular to each other, as the reason, what are the perpendicular diagonals? These are PR is perpendicular to OE. Now, diagonal OE divides the kite into two triangles. So, the area of the kite ROPE is equal to the area of triangle OPE plus the area of triangle ORE. And this is the area addition postulate. Now, by using the formula for the area of the triangles, that the area is equal to 1/2 times the base OE times the height PW. And the other triangle, ORE, is 1/2 times the base OE times the height WR. Then by factoring, look for common term, and that is 1/2 and OE. So factor it out. The area of the kite is equal to 1/2 times OE times the sum of PW and WR. So PW plus WR is equal to PR. And this is by segment addition postulate. Then, we have the area of the kite ROPE is equal to 1/2 of OE times PR. And that is by substitution using statements 5 and 6. Now let us see its application. Let us consider this illustration. Our given is kite MNOP, and if the length of NP is 20 centimeters and MO is 45 centimeters, find the area of kite MNOP. So using the idea of our theorem, that the area of kite MNOP is equal to 1/2 times the product of the lengths of our diagonals. So 1/2 times NP times MO. Then by substitution, the length of NP is 20 and the length of MO is 45. So multiplying 20 and 45, that is 900. And 1/2 of 900 is 450. Therefore, the area of kite MNOP is 450 square centimeters. Now let us look for another example. This is our illustration. So the given is kite QRST with the area of 27 square inches. We have to find diagonal TR if diagonal QS is given with the length measure of 9 inches. So using the idea for area of the kite, which is equal to 1/2 times the length of diagonals. So the area of kite QRST is equal to 1/2 times the length of diagonal PR times diagonal QS. Then by substitution, the given is area, so substitute 27 in terms of the area, and QS is 9. Then to eliminate 1/2, let us multiply both sides by 2. So we will get 54 is equal to PR times 9. Then dividing both sides by 9, we will get PR is equal to 6 inches. That's all I can share about the kite. I hope you learn in our discussion. And before we end, how well do you know this question? Quadrilateral is a kite. Is this statement A, always true? Or B, sometimes true? Or C, it can never be true? Try to share your idea by writing your answer in the comment section below. Thank you for watching. God bless everyone.